Dan. Dan is going to talk about Geofable, which is a tool for building map-based infographics, and I cannot wait to hear this. So an application about how we use PostGIS or Postgres under the hood, and he's going to talk about how he kind of develops that. So Dan, you've got about 5 to 8 minutes. Can you do it?
Yeah, I think so.
I have a pizza that I can eat while you're going through this.
Yeah,
so.
I don't have as many slides as Paul, but they're up there. And just before I get started, I want to say the one thing Paul didn't mention is that he also basically wrote PostGIS. And I know it's open source, so there's a lot of obvious, but I think it's fair to say he wrote at least half of it. And when you're Googling issues, he's really active on the forum, providing support for everyone. So thanks, Paul, for all the work in PostGIS and for making sure. And making sure that we're not all using Oracle Spatial. So I'm going to talk today about a project I've been working on called Geofable. But first I'll give a little introduction to myself. So my name is Dan. My background is in intelligence community contracting, and I work with analysts to help them make better use of their data. I wrote a book on Elasticsearch, and I'm an avid Postgres user. And so Geofable, at its core, is a tool for helping people tell stories with spatial data through map-based infographics. And the reason I came up with this tool is because building good-looking maps is hard. And governments and corporations basically hire entire teams of people to solve this problem. They hire graphic designers and geospatial experts and cartographers and programmers to build professional map infographics. And everyone from the US government to commercial sector to media companies follow this model. So Geofable is a tool that helps an analyst, someone who has data and someone who has a story they want to tell, build a good-looking map without being an expert in GIS and without being a graphic design expert. It lets them turn a spreadsheet of data into a map, and it's free to make public maps, and I'm in beta right now, so I'd love some feedback. It's got two components: the map builder, which lets you load data and style data, and then once you're done loading data, and it's time to share the map, you send someone a link, and then they get this kind of read-only view of the map with a description, and they can kind of interact with it, zoom in, and click on the various features. So architecture, it's in AWS, it uses Mapbox on the front end, uses Python, Postgres, PostGIS on the back end, using Elasticsearch for metrics tracking. This is the same slide as before, but I drew boxes around everything. And the core of what we're talking about today is PostGIS. So that is the main database that powers Geofable. So why PostGIS? Well, it's open source. It uses my favorite database, Postgres, in the back end. It's really performant. And I originally wrote it's the dominant open source relational database in the market these days, but really it's really establishing itself as just the dominant database. No SQL databases were kind of gaining steam in 2010 to 2015, but now people are really starting to realize that actually Postgres is fine for 99% of cases, and it's really fast and can scale to a lot of data, and it's got great geospatial capabilities. So some alternatives that I also considered. So there's Oracle, which is really expensive, and like Paul said, there is and is not performance advantages sometimes. Elasticsearch, I love using Elasticsearch. It has great geo capabilities, but at the end of the day, Post just did everything I needed. So it would have made my architecture a little more complicated to use Elasticsearch. Some other things, MongoDB is not relational, which is just personal preference. Wanted a relational database, and then there's some other options. ArcGIS and Carto can use Postgres under the hood, but they're not really a backend data store. So real quick, I'll talk about the data model. The goal for the data model is to let users load CSV files, Geo JSON, shape files, and keep the same data structure. So I came up with two tables, and there's more tables, but these are just the core ones. A dataset table, which is basically like a CSV file or a shape file that someone would have loaded into the platform, and then a dataset row, which is every column. And apologize for getting in the weeds here, but here's what the dataset table looks like, and dataset row, and here's the exciting part, the geospatial column. So everything outside of the red area is what you can do with Postgres, and inside the red area is what you use PostGIS for. So we have special geo data types and spatial indices on them. So about these spatial indices, basically you want to put an index on your data if you're doing any kind of spatial operation on it. I guess you don't need to if you're just pulling it from the database. It's easy to create an index, and a use case I've got for creating spatial indexes, let's say you've got point data that shows crimes in Washington, D.C., and a timestamp and a lat long, and then you have polygon data of the D.C. neighborhoods. So we want to build a heat map of that data. So what we're going to do is do a spatial join. This is a kind of a precursor warm-up example. This would just get the crime count in one neighborhood, and then using this join, we could get the crime count in all neighborhoods. So another thing you can do is automatically convert data to Geo JSON from PostGIS. So you can pull it out of the underlying binary form. So let's take that last query it did, and I'll post these slides, and you take the spatial join, and then you pipe it into a Geo JSON field, and then we take our point data of crimes, we take our neighborhood data, and then the end result is this kind of choropleth heat map with the join data all put together. So another big part of my workflow is Python. If you're using Python and PostGIS, you can do it two ways. You can use an object relational mapper, or you can use plain SQL. You have a little more control with SQL, but it can be a little verbose. And with the object relational mapper, you're using all Python all the time, but it kind of hides the SQL from you under the hood. So I'm using GeoAlchemy 2, which is kind of the PostGIS object relational mapper, and it has parallels for all of the spatial functions. So what ends up happening is your Python code starts to end up looking a lot like your SQL code. So again, we have our Python objects, we index it with a geospatial column, and really it's important if you're using an object relational mapper in Python to not forget that you're using SQL. So don't just pretend that you're doing all Python all the time. It's important to look under the hood and see what SQL queries it's generating for performance issues and for debugging. So another thing is use plain SQL when the queries get really complicated, because when you have a page-long query, it can be hard to do in pure Python, but if it's a really simple query, then just stick to Python. Then one of the coolest new features in PostGIS is generating vector tiles. So use Mapbox in the front end, and you can take a table from PostGIS and turn it directly into a Mapbox vector tile using this PostGIS function. And so here's the SQL version, and then we've got the Python version. And basically what it does is it really compresses down your tile. So here I've got a map of the world, and I've got this little area over India circled. You'll see there's no data there. But then as you zoom in, some data starts to appear. And then as you zoom in more, some more data starts to appear. So in this first slide, this is a big data set that's like, I don't know, not that big, but like 100 megabytes. But it's able to compress it down really small because it doesn't have to show all the features in the data set. And then it's able to load that 100 megabyte data set using only a couple kilobytes. I've got another example. This is power line data. It's the same thing. It's a 150 megabyte data set. But when we load this picture here, it's less than a megabyte because it's really simplifying and using those PostGIS functions under the hood to generate the vector tiles. And as we zoom in, we can see more detail. So right now with Geofable, I'm using vector tiles when you share your map with someone else, and it goes into the presentation mode. So I'd love to answer questions afterwards. And
yeah.
Thank you all very much.
Awesome. Thanks, Dan.